The 1996 National Electrical Code (NEC) started requiring the bonding of electrical parts of the pool water circulating system. The NEC mandates bonding of electrical parts within 5 feet of the pool. If equipment is located more than 5 feet from the pool and is not bonded, the following bonding methods should be considered. Firstly, bond all metal parts in the equipment area together. This includes pump motors, metal conduit, and other metal components. Secondly, run a bonding wire to the grounding grid. This is the preferred method, even if the distance is significant. It is forbidden to bond double insulated motors because the insulation is designed to protect against electrical shock without the need for additional grounding. Bonding a double insulated motor would compromise the insulation and defeat its safety purpose. Regarding older installations where equipment is not part of the bonding grid and the home inspector identifies it as not bonded, there are a couple of approaches to take to improve safety. One approach is to bond all the various metal parts in the equipment area together. This would involve connecting all exposed metallic parts of the pump motor, any metal conduit, metal enclosures, and other metallic components in the vicinity to create a common electrical potential. The other approach is to run a bonding conductor all the way back to the pool's bonding grid, even if the distance is 20 feet or more. This ensures that all metal parts in the equipment area are directly connected to the main bonding grid, providing a more robust and reliable bonding system. The preferred method is to run the bonding wire to the grounding grid, even if the distance is considerable. This provides a direct and reliable path for fault current to return to the source, helping to trip the circuit breaker or ground fault circuit interrupter (GFCI) more quickly and effectively. To understand why it's forbidden to bond a double insulated motor, it's important to understand the design and purpose of double insulation. Double insulated motors are designed with 2 layers of insulation between the electrical components and the outer casing. The first layer of insulation is the functional insulation, which is the primary insulation that insulates the electrical windings and other live parts. The second layer of insulation is the supplementary insulation, which provides an additional layer of protection in case the functional insulation fails. This supplementary insulation is typically a non-conductive material that is physically separated from the functional insulation. The purpose of double insulation is to provide protection against electric shock without the need for grounding. If a fault occurs in the motor, such as a breakdown of the functional insulation, the supplementary insulation will prevent the user from coming into contact with live parts. By not requiring a ground connection, double insulated motors can be used in a wider range of applications, particularly where a reliable grounding path may not be available. Bonding a double insulated motor would defeat the purpose of the double insulation and could actually create a safety hazard. If the motor were to develop a fault, the bonding connection could provide a path for current to flow to ground, potentially energizing the motor casing and creating a shock hazard. Additionally, bonding the motor could compromise the integrity of the double insulation, making it less effective at preventing electric shock. Because of these factors, it's important to always follow the manufacturer's instructions and never bond a double insulated motor. Doing so could create a dangerous situation and void the motor's warranty. In addition to the specific requirements for bonding pool equipment, it's also important to follow general electrical safety practices when working with or around pools. This includes ensuring that all electrical equipment is properly grounded, using ground fault circuit interrupters (GFCIs) to protect circuits near the pool, and avoiding the use of extension cords near the pool. By following these safety practices, you can help to prevent electrical shocks and other hazards. When assessing an older pool installation where the equipment is not part of the bonding grid, a comprehensive evaluation should be conducted to determine the best course of action. Firstly, identify all metal parts associated with the pool and its equipment, including the pump motor, filter housing, metal pipes, ladders, and handrails. Secondly, determine the distance of the equipment from the pool's edge. The NEC specifies that all metal parts within 5 feet of the pool's edge must be bonded together. Thirdly, inspect the existing grounding and bonding system. Check for any signs of corrosion, damage, or loose connections. Ensure that the grounding conductor is properly sized and connected to the main electrical panel. Fourthly, evaluate the condition of the pool equipment. Look for any signs of damage, wear, or deterioration. Ensure that all electrical equipment is properly rated for use in a wet environment. Fifthly, determine the most appropriate bonding method. If the equipment is located within 5 feet of the pool's edge, it must be bonded to the pool's bonding grid. If the equipment is located more than 5 feet from the pool's edge, consider bonding all metal parts in the equipment area together and connecting it to the pool's bonding grid. Sixthly, install the bonding conductors. Use solid copper conductors of the appropriate size, typically number 8 American wire gauge or larger. Connect the bonding conductors to all metal parts using listed bonding connectors. Seventhly, test the bonding system. Use a low resistance ohmmeter to verify that all metal parts are properly bonded together. The resistance between any two metal parts should not exceed 1 ohm. Eighthly, document the bonding system. Keep a record of all bonding connections, conductor sizes, and test results. This will be helpful for future inspections and maintenance. Remember that bonding is not the same as grounding. Grounding is the process of connecting electrical equipment to the earth to provide a path for fault current to flow back to the source. Bonding is the process of connecting all metal parts together to create a common electrical potential, reducing the risk of electric shock. Both grounding and bonding are essential for electrical safety in and around swimming pools. Also, it is important to ensure that all electrical work is performed by a qualified electrician. Working with electricity can be dangerous, and it's important to take all necessary precautions to protect yourself and others from electric shock. It is also necessary to consult with local electrical codes and regulations. The NEC provides a general framework for electrical safety, but local codes may have additional requirements or restrictions. It is crucial to be familiar with the applicable codes and regulations in your area before performing any electrical work. To further elaborate on the importance of bonding metal parts in the equipment area, consider the potential hazards that can arise if these parts are not properly bonded. Firstly, electric shock. If a fault occurs in the pump motor or other electrical equipment, the metal parts could become energized, creating a shock hazard for anyone who comes into contact with them. Secondly, corrosion. Stray electrical currents can flow through unbonded metal parts, leading to corrosion and deterioration of the metal. This can weaken the metal parts and increase the risk of failure. Thirdly, equipment damage. Stray electrical currents can also damage electrical equipment, such as the pump motor and filter. This can lead to costly repairs or replacements. Fourthly, fire hazard. In some cases, stray electrical currents can generate enough heat to ignite nearby combustible materials, creating a fire hazard. By bonding all metal parts together, you can create a common electrical potential, reducing the risk of electric shock, corrosion, equipment damage, and fire. The bonding conductor provides a low impedance path for fault current to flow back to the source, helping to trip the circuit breaker or GFCI more quickly and effectively. When selecting bonding connectors, it's important to use connectors that are specifically listed for bonding applications. These connectors are designed to provide a reliable and corrosion-resistant connection between the bonding conductor and the metal part. Avoid using wire nuts or other general-purpose connectors for bonding, as these may not provide a secure and reliable connection. When installing bonding conductors, it's important to follow the manufacturer's instructions and use the appropriate tools. Tighten all connections to the specified torque to ensure secure and reliable connection. Avoid over-tightening the connections, as this could damage the connector or the metal part. When testing the bonding system, use a low-resistance ohmmeter that is specifically designed for testing bonding and grounding systems. These meters are capable of measuring very low resistances accurately and reliably. Before testing, make sure that all power to the pool equipment is turned off. Connect one lead of the ohmmeter to a known good ground, such as the grounding electrode conductor. Connect the other lead of the ohmmeter to each metal part that is bonded. The resistance between each metal part and the known good ground should not exceed 1 ohm. If the resistance exceeds 1 ohm, there is a problem with the bonding connection and it needs to be corrected. Consider the specific requirements for bonding metal parts associated with different types of pool equipment. For example, the pump motor must be bonded to the pool's bonding grid. The filter housing must also be bonded to the pool's bonding grid. Metal pipes must be bonded to the pool's bonding grid at each end. Ladders and handrails must be bonded to the pool's bonding grid at each point where they contact the pool structure. By following these specific requirements, you can ensure that all metal parts are properly bonded and that the pool is safe to use. Also consider the potential for stray voltage in the pool water. Stray voltage is a small electrical voltage that can be present in the pool water due to various factors, such as faulty wiring, improper grounding, or nearby power lines. Stray voltage can cause a tingling sensation or even a shock when someone comes into contact with the water. To minimize the risk of stray voltage, it's important to ensure that all electrical equipment is properly grounded and that the pool's bonding system is properly installed and maintained. You can also install a sacrificial anode in the pool water. A sacrificial anode is a piece of metal that is more easily corroded than the other metal parts in the pool. The sacrificial anode will attract stray electrical currents, preventing them from corroding the other metal parts and reducing the risk of stray voltage in the water. If you suspect that there may be stray voltage in your pool, contact a qualified electrician to inspect the electrical system and take appropriate measures to eliminate the stray voltage. Remember that electrical safety is paramount when it comes to swimming pools. By following the recommendations outlined by the NEC and consulting with qualified professionals, pool owners can ensure a safe environment for everyone to enjoy. Lastly, the size of the bonding conductor is also a critical aspect of pool bonding. The NEC specifies the minimum size of the bonding conductor based on the size of the circuit conductors supplying the pool equipment. In general, the bonding conductor must be at least as large as the largest circuit conductor supplying the equipment, but not smaller than number 8 American wire gauge copper. For example, if the pump motor is supplied by a 20 amp circuit using number 12 American wire gauge copper conductors, the bonding conductor must be at least number 12 American wire gauge copper. However, if the pump motor is supplied by a 30 amp circuit using number 10 American wire gauge copper conductors, the bonding conductor must be at least number 8 American wire gauge copper, as this is the minimum size allowed by the NEC. It's important to consult the NEC for the specific requirements for bonding conductor size, as these requirements can vary depending on the size of the circuit conductors and the type of equipment being bonded. Using the correct size bonding conductor is essential for ensuring that the bonding system can effectively carry fault current back to the source, helping to trip the circuit breaker or GFCI more quickly and effectively. In addition to the size of the bonding conductor, the type of conductor is also important. The NEC requires that bonding conductors be made of solid copper or other corrosion-resistant material. Stranded conductors are not allowed for bonding, as they can be more susceptible to corrosion and may not provide a reliable connection. Solid copper conductors are the most common choice for bonding, as they are readily available, relatively inexpensive, and provide excellent conductivity and corrosion resistance. When installing bonding conductors, it's important to avoid creating sharp bends or kinks in the conductor. Sharp bends can reduce the conductivity of the conductor and can also make it more susceptible to damage. Use smooth sweeping bends whenever possible to maintain the integrity of the conductor. It's also important to protect the bonding conductor from physical damage. If the conductor is exposed to the elements or to potential physical damage, it should be protected by conduit or other suitable means. This will help to ensure that the conductor remains intact and that the bonding system remains effective. Also, it is good practice to inspect the bonding system periodically to ensure that all connections are tight and that the conductors are in good condition. If any problems are found, they should be corrected immediately to maintain the integrity of the bonding system. When making bonding connections, it's important to use listed bonding connectors that are specifically designed for the purpose. These connectors are designed to provide a secure, corrosion-resistant connection that will withstand the harsh conditions around a swimming pool. Avoid using Y-nuts or other general-purpose connectors for bonding, as they may not provide a reliable connection and may be more susceptible to corrosion. Additionally, it is important to ensure that the bonding conductors are properly identified. The NEC requires that bonding conductors be identified by a green color or by a tag or label that indicates that they are bonding conductors. This will help to prevent accidental disconnection or damage to the bonding conductors. Lastly, always remember that electrical work can be dangerous and should only be performed by qualified professionals. If you are not comfortable working with electricity, consult a qualified electrician to perform the bonding work for you. By following these guidelines, you can ensure that your pool's bonding system is properly installed and maintained, providing a safe and enjoyable swimming environment for everyone.